Hi everybody, I want to show you how to use the Goodness of Fit template in the template that I gave you in class. So this is question number 26 on the homework, and it's asking you to do a hypothesis test for goodness of fit. Here's how I recognize it, is that I have many categories. I've got some counts, and I want to see if they have the same frequencies, okay, as each other. Or another way that you would use goodness of fit is if they give you frequencies that you want to see if your data matches those frequencies. And in this case, we have to have more than two groups. If we had two groups, we'd go back to a two-sample hypothesis test like we did in week 6. But this is more than two groups. We're comparing frequencies or counts. And that tells you that we've got goodness of fit. Okay? So what we're claiming, here's the claim in the question: the different days of the week have the same frequencies. So they mean the same frequencies as each other. So for example, they mean that you wouldn't get more calls on a Monday than you would on a Thursday, for example, or more on a Saturday than you would on a Wednesday. They're saying that they expect to have all the same frequencies. So in the template that I gave you, the goodness of fit is different than what he does in the videos. Let me clean this up a little bit so you can see everything. So here is the goodness of fit tab that I have. This will go and work all the way up to 100 pieces of data for your entry. You don't have any homework that has that many, but I wanted to make sure that it would work no matter what. Here is where you're going to put your actual data, and it has to be counts. So I'm going to take that out. Here are the frequencies. This would be your expected right here. So your actual is in column A, your expected is in column B, and then here's your alpha value over here. And we're usually using a 0.05, so I'm going to put in a 0.05. But of course, like always, they'll tell you what the alpha is. The alpha is the amount of risk that you are willing to take to make a type 1 error. Okay? And in practice, you get to decide that on your own, on the homework they tell you. So let's take a look at our data. We have 1, 2, 3, 4, 5, 6, 7, because we have 7 days of the week, and I'm going to enter those into the counts, into column A. So on Sunday, I have a 156. Tuesday, I have a 205. Tuesday is a 220. Wednesday is a 250. Thursday is a 176. Friday was a 210. And Saturday was a 237. Now we have to figure out what our expected would be. Those are going to be frequencies. Okay. We expect all of our frequencies to be equal for this one. They're not giving us a bunch of frequencies that we need to match. I think the Bedford's Law problems have some frequencies that you need to match. And in that case, you would just type them into this column, type them as decimals. But in our case, we expect them all to be equal. There are 7 days of the week, so I would expect each frequency to be 1/7. So I'm just going to type that in, equals 1 divided by 7. And I'm going to fill that in down the row. Whoops, not 1 divided by 7. And then actually I can just fill this down. And you can see as I'm filling this down, everything over on the right is filling in as I go. So now it's all completely filled in. Okay, there's our significance. Okay, here's your chi-squared value. Here is your p-value, and here are your critical values. So you would interpret these the same way you would any other hypothesis test with your p-value, compare your p-value to your alpha, or look at your test statistic and see where it lands in relation to your critical value. The chi-squared is your critical value. Now over here, there's another little table. Some of your homework problems don't give you the data. They give you the chi-squared value. So in that case, use this part of the table because they tell you the chi-squared value. Don't use this table on the left at all. Just input it there. So that's that. Thanks. I'll see you in class. Bye-bye.